problem as posted on Wyzant. Probably too hard to see this, so let's go to board 2 and look at a Desmos graph that graphs these functions. R of x is the river, the blue dashed graph. There's the function right there. Polynomial function except for this last term here. H of x is the function that represents the red graph, which is the highway. So this is the highway. And the blue graph is the river. And origin town is a city with center at the origin, 0, 0. And P of x is a straight path from the center of origin town to the river. And they ask, what's the domain of P of x? Well, first of all, it might be nice to know what the function looks like. But it's a straight line, so if we could find the slope of that line, well, if we put 1/2 into the river function, whatever r of 1/2 is, minus 0, because that's the coordinate, y coordinate of origin town, divided by 1/2 minus 0, that would be the function times x, because the y-intercept is at 0. But the real question is, what was the domain? Well, once you get to the river, there's no bridge there. You can't cross it. So it looks to me like x can be the domain is x is between 0 and 1/2. If you go greater than 1/2, you're in the river. Okay, so that's the answer to the first part. The second part is, what is the coordinates of these bridges where the highway crosses the river? And on Desmos, I was just able to click on the points where the two graphs intersect and get the coordinates. So there they are. There they are. The intent for you is probably to use a graphing calculator and type in graphs for y sub 1 and y sub 2, and then use functionality on the graphing calculator to find the points of intersection. Another possibility is to use Newton's method. So if we say, when does r of x equal h of x, you can get a function like f of x equals r of x minus h of x, and find out when that equals 0. And using Newton's method, if I share my screen, share graph, no, not share graph, share screen. Why is that? Share screen. There's that function, and Newton's method, maybe you have heard of it, maybe you haven't, allows you to approximate the roots. And there is the x-coordinate of the first bridge out to many more decimal places. We rounded to 0.35995. But you can get a lot more decimal places. And then if I change the starting coordinate to 3.5, there's the x-coordinate of the bridge to quite a few more decimal places. Okay, that's Newton's method. We'll go over Newton's method. The final question, there's two final questions. We build this road north from origin town. We want to know how far it is to the highway. Well, all you have to do is find h of 0. Because when x is 0, that's the point of intersection of the highway with this road that we've built. So h of 0, if I put 0 in here, 3 to the 0 is 1. 1 times a half is a half. A half plus 1 is 3/2. So the coordinates of this point right here is 0, 3/2, and that's the distance from origin town to where the road meets the highway. And will the road ever, uh, this green road ever cross a bridge across the river? No, it'll never even meet the river because for the river, x has to be greater than 0 because you can't put 0 in for x here. So the green road from Morgantown north will never hit the river, so it'll never hit a bridge. There you go. Hope that helped. If you have any questions, post a comment.